Good day, my dear viewers at home. My name is Mr. Okafor, Akimos Mathematics JS3 instructor. Today we are going to consider another important topic, term binary numbers. First of all, ask yourself a question: what is binary numbers? And we say it's just counting in twos or counting in base twos. Like in binary number, we have only two numbers, 0 and 1. But in computer, for binary number, then we are going to consider this topic into 4 different subtopics. Convert binary number to base 10, convert number in order base to base 2, or binary number, addition and subtraction of binary number, and multiplication and division of binary numbers. So let's start. Convert binary numbers to base 10. For example, I have example 1. I have 110001 base 2. Change it to base 10. Change 110001 base 2 to base 10. The first step is we have to do what? We have 110001 base 2 to base 10. The first thing we need to do is to find their powers, indices. We powered it. Here we give. Okay, good. The next step is to multiply the binary numbers with the base. Let's start. 1 times 2 plus 1 times 2 plus 0 times 2 plus 0 times 2 plus 1 times 2. That's the next step. Then we'll bring back the powers, indices. Raised to power 0, raised to power 1, raised to power 2. Excuse me, please. I'm going to multiply this with the base, which will give us 1 times 2 plus 1 times 2 plus 0 times 2 plus 0 times 2 plus 0 times 2 plus 1 times 2 to give us this. Now we'll bring back the powers. Raised to power 0, raised to power 1, raised to power 2, raised to power 3, raised to power 4, and raised to power 5. Then we're going to go back to indices. Our work with indices. This is just the same thing as 1 times 2 times 2 times 2 times 2 times 2 plus 1 times 2 times 2 times 2 times 2. Here, there's no need to stress yourself. Anything multiplied by 0 is 0. Plus 0, plus 0, plus 0. Then we have here 2 raised to power 0 is 1. Please note, anything raised to power 0 is 1. Mr. Okafor raised to power 0 is 1. Whatever raised to the power of 0 is 1. Then we are going to add 1. 2 times 2 times 2 times 2 times 2 will give us 32. Plus 2 times 2 times 2 times 2 will give us 16. Plus 0, plus 0, plus 0, plus 1. Then let's add. 32 plus 16 will give us 48. Plus 1, the answer will be 49. Base 10. That's the final answer. Let me explain again. Example 1. We have changed 110001 base 2 to base 10. The first thing you need to do to assign the powers 0, 1, 2, 3, 4, and 5. Then we expand this number times the base. That's how we get this. Then we put back the powers. Then we'll use our index knowledge. This means 2 raised to the power 5 is 2 multiply itself 5 times. So that's how we get 32. This one we get 16. Anything multiplied by 0 is 0. Any number raised to the power 1 is 1. 1 times 1 is 1. So we add this to get 49. Example 2. Example 2. Change 1011 base 2 to base 10. We use the same step or method. Please put back the power raised to power 1, raised to power 0, raised to power 1, raised to power 2, and raised to power 3. Then we'll expand. 1 times 2 plus 0 times 2 plus 1 times 2 plus 1 times 2. Here is raised to power 0, raised to power 1, raised to power 2, and raised to power 3. And we have 1 times 2 times 2 times 2. Raised to power cube means multiply 2 is 3 times. Plus any number multiplied by 0 is 0. Then plus 1 times 2, 2 raised to power 1 is 2. Any number raised to power 1 is that number, which gives us 2, plus 1 times 1, which will give us 1. Then we have 2 times 2 times 2 is 8, plus 0, plus 2, plus 1, which will give us 11 base 10. Okay, let's check the next topic, convert numbers in order base to binary numbers. Convert number in order base to binary numbers. Example 1. Example 1. I have 3, 7, 4, base 10. Ask us to change it to what? Base 2. Change it to base 2. Sorry, convert 3, 7, 4 to base 2. Here is another different case. What we are going to do is as simple as ABC. What we are going to do, we are going to divide through with the base, and we'll have a shape that looks like this. The middle one will be the what? The dividend will be here. 3, 7, 4. The divisor, which is 2, will be here, and the remainder will be here. Let's start. 3 divided by 2 will give us 1, remainder 1. We'll put that one here, turn to 17. 17 divided by 2 give you 8, remainder 1. Put that one here, which will give you 14. 14 divided by 2 give you 7, remainder 0. Put the 0 here. Then we divide again by 2. 18 divided by 2 will give me 9. 7 divided by 2 give me 3, remainder 1. I have 2 again, will go. 90 divided by 2 will give me 4, remainder 1. Put the 1 here, turn to 13. 13 divided by 2 give me 6, remainder 1. 2 again will go. 2 divided by 2 give me 2. 4 divided by 2 give me 2. And 6 divided by 2 give me 3, remainder 0. And 2 will still go. 2 divided by 2 is 1. 3 divided by 2 give me 1, remainder 1. 2 will still go. And 2 go here. Will give me 5 remainder. Give me 5, remainder 1. And, sorry, let me bring it up here. 5 will go. 2 will go into 5. Give me 2, remainder 1. And 2 will go into 2. Give me 1, remainder 0. 2 goes here. Carry this one over here. Give you 1, bring this 0 down here, you have 1. Then we'll pick our answer from the bottom. 1, 0, 1, 1, 1, 0, 1, 1, 0. Base 2. This is our answer. 101, 111, 0110. Okay? That's the answer. Example 2. Convert 124 base 5 to base 10. Firstly, you have to change this 124 base 5 to base 10. We do number 1 times 5, we times with the base, plus 2 times 5, plus 4 times 5. Remember, here is 0, 1, and 2. We put it here. Raised to power 0, raised to power 1, and raised to power 2. Which will give us 1 times 5 times 5, plus 2 times 5, plus 4 times 1. 5 times 5 is 25, plus 10, plus 4, which will give us 35 and 39. The answer is 39 base 10. Then we convert 39 back to base 2. 39. 39 will be here, 2 will be here. 2 going to 39 will give us 1 remainder 1. 2 going to 19 will give me 9 remainder 1. Then 2 divided 19 will give me 9 remainder 1. 2 divided 9 will give me 4 remainder 1. 2 divided 4 will give me 2 remainder 1. And 2 divided itself will give me 1 remainder 0. And 1 divided by 2, carry this one over here, write it 0 that way. Then pick the answer from the ground or bottom. We have 1, 0, 1, 1, 1, 1, base 2. That's for that. Divided by 2. 39 divided by 2 gives us 19 remainder 1. 19 divided by 2 will give you 9 remainder 1. And 9 divided by 2 will give you 4 remainder 1. 4 divided by 2 will give you 2 remainder 0. And 2 divided by itself will give you 1 remainder 0. And 2 divided by 1 divided by 2 give you 0 remainder 1. So the answer will be 1, 1, 0, 0, 1, 1, 1, base 2. 1, 0, 0, 1, 1, 1, base 2. That's for that. Then let's go to the third one. Addition and subtraction of binary numbers. Here we have a serious issue. Although it's simple, but there are some certain laws you need to know while solving addition and subtraction of binary numbers. Okay, addition and subtraction of binary number. Before you solve addition and subtraction of binary number, you have to know these rules or laws. 0 plus 0 is what? 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 is 0. Note, in binary number, 1 plus 1 is 2. But we do not have something like 2 in binary number. It's equivalent to 1 and 0, which we will write 0 and carry 1. That's why it's 0. It's 0. Then here we have 1 plus 1 is 10. That's why we have this. We write 0 and 0. You know, in our normal addition, I have 1 plus 9. We used to write 1 and 0. But when you are adding, you are not going to write 1 and 0. You write 0 and carry 1. That's what happened here. Then the next one is 0 minus 0 is 0. 1 minus 0 is 1. And here we have another problem. 0 minus 1 equals to 1. For example, I have 111 minus 110 minus 11. What I'm going to do, I will borrow from here. As I'm borrowing here, it's not 1, it's going to be 2. 2 minus 1 will give me 1. I will borrow here again. You know, 2 in base 2 is 10. So I borrow here, give me 2. 2 minus 1 will give me 1. That's how we get 0. 0 minus 1 will give me 1. And 1 minus 1 is simple, is 0. Then let's go. Example 1. One, 1, 1, 0 plus 1, 0, 1, 1. Let's add. 0 plus 1 is 1. 1 plus 1 is 10. We will write 0 and carry 1 over here. Then 1 plus 1 is 10 plus 0 still 10. Write 0 and carry 1 here. 1 plus 1 plus 1 plus 1 is 3. If we convert 3 to base 2, we have 1 remainder 1, 2 go here, 0 remainder 1, which will give us 1 and 1. So in base 2, 3 is 1 and 1. So answer gives us 1, 1, 0, 0, 1 base 2. Okay? Example 2. One, 1, 0, 1, 1, 1 plus 0, 1, 1, 1. Okay, let's add. 1 plus 0 is 1. 1 plus 1 is 0, carry 1. 1 plus 1 plus 1 plus 1 give me 11, 1, 1. We write 1 and carry 1. 1 plus 0 is 1, plus 1 give us 10. We write 0 and carry 1. 1 plus 1 is 10, which is 2. Write 0 and carry 1. 1 plus 1 is 10, 1 and 0. So our answer gives us 1, 0, 0, 0, 1, 0, 1 base 2. That's for addition. Let's check subtraction. Example 3. One, 1, 1, 0 minus 1, 1, 1. Let's solve. 0 minus 1 is impossible. What we do, we borrow from here. As we are borrowing from here, that 1 can come in here will be 2, here will remain 0. 2 minus 1 will give me 1. 0 minus 1 is impossible, we still borrow from here to give us 2, here remains 0. 2 minus 1 will give us 1. Borrow from here, here remains 0, here will be 2. 2 minus 1 will give us 1. So our answer will be 1, 1, 1 base 2. Then example 4. Example 4.
No.
1, 1, 0, 1, 1, minus 1, 1, 0, 1. This minus this is 0. This minus this cannot. I'll borrow from here. Which is, this minus 0, sorry, is 1. This minus this cannot. I'll borrow from here to put here, give me 2, here remains 0. 2 minus 1 is 1. Borrow here again, here remains 0, here will be 2. 2 minus 1 is 1. So our answer is 1, 1, 1, 0 base 2. That's for addition, subtraction, addition and subtraction of binary number. Then the last one, multiplication and division of binary number. Example 1. One, 0, 1 times 1, 1. Here we're going to use our normal multiplication system. But after the multiplication, we'll do what? We'll add. That's what is going to happen here. 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1, 1 times 1 is 1, 1 times 0 is 0, 1 times 1 is 1. Then we add. Addition coming, bring in 1, bring down 1, 0 plus 1 is 1, 1 plus 0 is 1, bring down 1, in 1, 1, 1 base 2. That's example 1. Then example 2. Example 2. 1, 1, 1, 0 times 1, 0, 1. Let's solve. 1 times 0 is 0, 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1. 0 times 0 is 0, 0 times 1 is 0, 0 times 1 is 0, 0 times 1 is 0. 1 times 0 is 0, 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1. We add. Bring down 0, 1 plus 0 is 1, 1 plus 0 plus 0 is 1, 1 plus 0 plus 1 is 10. You write 0, carry 1, bring it here. 1 plus 1, 0, carry 1. Here give you 0 and 1. 1, 0, 0 is 2. Here is where we usually have problem, division of binary numbers. There are 3 methods of solving it, but we are going to use only 2 methods. The third one is troublesome. I'll teach you successive subtraction and change the number back to base 10. Then you subtract, you divide, then you change the answer back to base 10. Let's solve. I'll use one example to give you what I mean. 1, 1, example 1, 1, 1, 0, 0, 0, divide by 11. First thing to do, I'll convert this back to base 10, which will give me 1 times 2 times plus 1 times 2 plus 0 times 2 plus 0 times 2 plus 0 times 2. Here is 0, 1, 2, 3, and 4. 4, 3, 2, 1, and 0. Here is already 0. Here is 0. Here is 0. 2 raised to power 3 is 8. And 2 raised to power 4 is 16. Then we'll add. 16 plus this will give us 24. I have 24. Base 10. Then we change this. Divide by 1, 1 is descending as base 2. Descending as 1 times 2 plus 1 times 2. Base 0 and base 1. Raised to power 0 and 1. This is 1 already. Plus here is 2. Give us 3. We have 3. Then we go to this stage. 24 divided by 3 will give us 1 divided here, 3 divided here is 1, 3 divided here is 8. Then what are we going to do? We change back 8 to base 2. This is 8. 2 go here, 4 remainder 0. 2 go here, 2 remainder 0. 2 go here, 1 remainder 0. And 2 go here, 1 remainder 0. And 2 go here, 0 remainder 1. So our answer will be 1, 0, 0, 0 base 2. Let's try with the other method so that we can confirm if we are correct or wrong. Thank you for listening to me. Please, there are other methods to use to solve this division of